Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we are going to jump right into it. We're going to get on to lesson 4.3. Spent a lot of time on 4.2. I'm going to get through 4.3 in one lesson. You watch, it's going to happen, okay? So let's go ahead and jump right into it. Go ahead and look down into your book. We are on page number 61. 4.3, functions of special angles larger than 90 degrees. And they get right into it. There's no explanation. It just jumps right into an example. I'm not going to do this example. I'm just going to walk through it with you. Find the trigonometric function values of 270. So what they say is we can do this by graphing a 270 degree angle in standard position. What does that mean? So we're going to graph it right here, and then in standard position basically means that the initial side of the angle is going to be on 0. Graph it here at 270 degrees. So it's right here. So now they say, let's go ahead and let's put a coordinate point on here. And so we're going to be at 0 on the x and -1 on the y. So that's where our point is going to be. So remember, we have the initial side here. The terminal side is then going to be on the y-axis. So it's going to have a 0x. And that you could really kind of use any one that you want, any y value, but the y value, any negative y value. But the y value that they choose is -1, okay? And so they just say, all right, so we have the point of 0, -1. Now what we would do is plug that into the Pythagorean theorem, and we're going to get that the r is 1. Now we would just go through and plug it in everywhere. So the sine of 270 is the y is -1 and the r is 1. That gives us a sine of -1. That would also give us a cosecant of -1 because we just flip that and we still have -1. We would get the cosine of 0. Now this is important to understand. Notice our 0 is the numerator. Where did we get 0 from? Well, 0 is the x number over here. So 0 is the numerator. So that means when you divide 0 by 1, you get 0. Now when we flip that and we do the secant, so we do the reciprocal function, we would put 1 over 0. Now, when you plug 1 over 0 into the calculator, it tells you like math error or undefined, something like that. You can't do it. It's not a thing. So there's a difference. 0 and undefined are different. So don't put 0 for secant because it's not 0. You have to put undefined. It's very important. When you do the tangent, you would get 0 as the denominator again. That is undefined. You flip it back for the cotangent and you end up with 0. All right. So I said I wasn't going to go over that. I'm not going to take the time to go through all of it specifically because they give you this chart right here. Table C. Remember, whenever you see table in the book, it's very important. So here they give you the degrees, 0, 90, 180, 270, and 360. Remember, these are the quadrantal angles right there. The quadrantal angles. They give it to you also in radians. Make sure you memorize these radians right here. These radians are important. 0, pi over 2, pi, 3 pi over 2, and 2 pi. You should already be really familiar with, well, 0 makes sense, but you should be really familiar with the 180 equals pi, and then you just divide, look, 180 divided by 2, okay, so that's easy, and then 180 times 2 gives you 360, look, 2 pi. 2 times pi, 2 times 180. The 270 is the one that you're going to have to memorize. 270 is 3 pi over 2. Then you're going to want to know these right here. Do you have to memorize this? I would say no, but you better know where to find it. You better be able to go to table C and get it, or you better be able to build it. In other words, you better be able to go to the Cartesian plane, graph it on there, work your Pythagorean theorem. You better be able to find it, or you better be able to know how to get it in your book by going to table C. So I'm not going to make you memorize that one, but you should be very familiar with it. You'll see how this all comes together here in a few lessons, and we're going to put just a bunch of stuff together in one massive, huge chart that you can continue to go back to all the time. All right, so example 2. Find the trigonometric function value of 120 degrees. Now this one is not on your quadrantal angle list. So what are we going to do with this? Well, 120 is in quadrant 2. So we would plug into the theta equals the 180 minus your rho and plug that in, and we're going to end up with 60. As soon as we see 60, it should go, bing, 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 bing. Your mind should go, I know this. I know the 30, 60, 90 triangle. And so you're going to draw your 30, 60, 90 reference triangle, choose the sides of -1, 2, and square root of 3. Where does that come from? Okay, that comes from the front cover of your book. That comes from a lesson that we did. You have to know this. By this time they're expecting you to know that information. But those are the sides of your triangle. Now, why did they choose -1 instead of 1? Because, okay, let's go back to this. Look, it is in the second quadrant. It's 120 degrees. So we're coming negative on the x. This -1 is the x. Okay, so that's important to remember there. If it was a positive angle, and then we'd be going in to the right. But this is a negative because we're in quadrant 2, so we're going negative on the x. And notice here, all students take calculus. They put it into the second quadrant. In the second quadrant, sine is going to be positive. So again, let's go back up to what are we doing here? Example 2, find the trigonometric function. So we're going to find them all. So we're going to do this same process for all of them. So draw this right here. Why do you want to draw this? Because you have right here, once you draw it, you have everything you need. What is the -1? That's the x. What is the 2? That's the r. What is the square root of 3? That's the y. Okay, so you have everything you need and you just keep building. What I would do personally is, let me come back over here and let me show you how I would do this. It's similar to how they did it, but the way I like to do these is I like to actually say, okay, my x equals, and then I write the x value. So in this case, it's -1. My y value in this example is the square root of 3, and my r value is 2. I like to make a little box, basically, and I like to write what each one is. And then as I go through the different ones, I can always refer back to, okay, what was the x? I need x here, I need r here, and then you just plug in. So going back over here to the book, we're just going to keep going down through it. Now we go to cosine, and then we go to tangent, and then we go to cotangent. So let me show you the way that this kind of all fits together here. So let's do sine. Let's start with sine. Another thing I want to write here is I want to write my all students take calculus, and I want to make sure that I remember, okay, we're in the second quadrant. So no matter what one I'm working on, I'm always in the second quadrant, so I need to remember that. So when I have sine, I'm remembering, okay, sine in the second, that's positive. All right, good. So sine is what? Sine is y over r. So we're just going to put y over r. And we're done. Okay, that's sine. And then we'd come down, and you can do it however you want to. I'll just do it cosine, and then tangent, and then over here I will do the cosecant, the secant, and the cotangent. I'll do it that way. All right, so our cosine is going to be what? Well, let's compare it to this first. So sine is positive, so that means that cosine is going to be negative, so that's going to be a negative right there. And we're going to have x over r. X is -1, so there's our negative, and you can attach it to the 1 if you want, or you can attach it to the fraction. I typically attach it to the fraction, not to the actual number, not to the numerator, because we all know that the denominator is positive, the r is positive. Now we'll go to the tangent, and remember I'm looking back here, and this is sine, so tangent is also going to be negative, and so I'm going to have y over x, so that's going to be square root of 3 over 1. See, that's negative 1. All right, I have the negative 1 written there, but there's the negative right there. Technically, it does go with the 1. For the cosecant, now this one's going to be just a little bit trickier, but what we're going to do here with the cosecant is we're going to do 2 over the square root of 3. Now that is not a good fraction, is it? All right, we've talked about that. We have to rationalize that denominator. So you would multiply everything by the square root of 3, and it would come out to, you would have 2 square roots of 3 over 3. That is positive because since sine is positive, cosecant is also positive. Why? Because the y is positive and the r is positive. So when you flip it, it doesn't change the positivity of it. It stays positive. Just like when you flip cosecant to secant, it doesn't change the negativity. It stays negative. All right. So what we'll do with secant is we'll flip that and we just get a 2 over 1, or we just get a 2 negative 2. I don't care how you write that. If you want to write it negative 2, fine. If you want to write it negative 2 over 1, leave the fraction. That's fine with me too. I typically leave it with the fraction personally because then I realize, okay, I am dealing with a trigonometric function. It's not just a 2 sitting there. And then you would do the same thing with cotangent. Remember, once we have the square root of 3 on the bottom, we have to rationalize that. So we get the square root of 3 on the top. Once we rationalize it, I'm not going to show you the process because I think you already know the process. And we get a 3 on the bottom, and that is negative because tangent is negative, so cotangent is also going to be negative. I don't really like the way that turned out. Let me change this real quick. Cotangent negative. There we go. You can see that a little bit better now. Okay? And so that's the way that you work through those, and that's the way that you rationalize denominators, and that's the way that you use that chart to kind of work through that. You would do the same thing if you are dealing in radians. Look at example 3 in your book on page 63. I'm not going to go through this one because I just went through it with you with the degrees, but if we are looking for radians, we are going to find the reference angle, the rho, for 5 pi over 4. Once we put that into our triangle, we see that it is going into the third quadrant. So we would go back and we would do our all students take calculus. They have it right here. We would circle the t because it is in the third quadrant. So now we know that tangent is going to be positive and cotangent. Sine, cosine, secant, cosecant, those are all going to be negative. Put it through to your reference angle, and in this case we end up with 180. Since it's in the third, we'd have 180 plus this, and we would come out with rho equals pi over 4. Once we put it in pi over 4, we would realize, hey, pi over 4, that's a 45-degree triangle. I know the 45-degree triangle, so we'd put -1, -1, and square root of 2. Why isn't it 1, 1, square root of 2? Because our x is negative and our y is negative. So that's going to be a negative here. And then you just plug it in. You just go back through sine, cosine, and tangent, plugging in the 1, -1, or the 2 negative ones and the square root of 2. Once you go through that whole process, rationalize all the denominators, you can look there and you come out with your answers. Okay, and that's really all it has for you. Then this, I want to show you this because this is epic. Okay, this moment that we've gotten to right here. You need to fill in this chart, and you can do it, almost all of it, you can do it from other charts that we've had. Okay, the radians you can fill in from other charts. If you can't, then you can do them on your calculator. This is so important. No, well, it says copy the complete file without the calculator. Okay, so forget I said with the calculator. So do the radians based on all the other charts that we have. You can work them out and then go through these and all of these example problems that we've just done. So this example problem, that's the 45, 45. This example problem, this is the 30, 60, 90. And then this example problem, this is the quadrantal angles. So take those examples. All you have to do is go to those examples. You don't have to rework them. It's already worked for you. We've already done that in this video. We went through those. And so notice 0, 30, 60, 90, 45. Okay, these are the special angles right here. Notice in this next set, these are just the special angles in quadrant 2. Then you have here 210, 225. These are the special angles in quadrant 3. And then you come down here to 270, 300, 315. Those are the special angles in quadrant number 4. So all you're doing here is you're filling in all of the information based on those charts that we've done. What happens here is you just keep repeating the same things, but you better be careful, because then now all of a sudden we have negative, because now look, we're in the second quadrant. Sine is positive in the second quadrant, but when you come down here into the third quadrant, sine is negative. So when you're in the fourth quadrant, sine is negative again. So be careful on these. Make sure your signs are correct. Make sure that everything is correct. This piece of paper right here, this exercise, is so important, because you're going to spend a lot of time looking back to this. It's going to be like a reference guide for you on future quizzes and future homework assignments, things like that. So this, make sure you do it right, and make sure that you check it for accuracy, because you're going to want to continue to come back to this number 7, exercise 4.3, and continue to use it throughout the year. So make it like a chart, a guide for you. Okay? All right, well, that's all I have for you in this lesson. Go through those exercises, try those, make sure that you work through them, and do your best. If you need some help, rewind this video, watch it again, and hopefully you can understand if you missed anything there, okay? We'll see you later. You have a good one. Bye-bye.